Today in class we continued to cover graphing rational expression or functions. And so we learned a couple of things. We learned about functions, and these are functions such as f of x is equal to 4x over x squared minus 4x. And when we are graphing these or figuring out how a graph is going to look for these type of functions, the first thing we need to do is to factor both the numerator and the denominator. And I'll be doing a lot of abbreviations. So in this case, f of x is equal to 4x over x squared minus 4x. My numerator obviously cannot be factored out, but my denominator, if you look at my denominator, I have an x in common with both terms. So I'm going to factor out an x, and x squared divided by x is x, and it leaves me x minus 4 inside the parentheses. So that was my first step, I factored. My second step is to see if any factors are common in both numerator and denominator. And I'm just going to abbreviate N and D. So in this case, I'm looking, I don't have a 4 that's a factor by itself, but I do have an x. So in this case, x is equal to 0 is going to be a hole or a point where the graph is going to become discontinuous. So it says, see if any factors are in common in both the numerator and denominator, set equal to 0, and solve for x. And in this case, it's just x, and so x is equal to 0. The third thing we're going to work on from there is the vertical asymptotes. And vertical asymptotes is, I see if there are any other factors than the holes in the denominator, set equal to 0, and solve for x. So in this case, I set x minus 4 equal to 0. It's what's left up here. And x is equal to 4. There is a vertical asymptote. I'm going to zoom out a little bit. So the next thing I'm going to look for is my horizontal asymptotes. In horizontal asymptotes, there's a few rules that I need to look for or use. And I'm looking at the degrees of my numerator and my denominator. And then once I find the degree, or I should say compare, degree of num and denom, and if the numerator degree is less than the denominator degree, then I have a horizontal asymptote at y is equal to 0. So that's situation A. B is numerator degree is greater than denominator degree. Then I have the situation where there is no horizontal asymptote. And the C situation is when they are equal to each other, to denominator degree. And this is where y is going to be equal to A over B. And A is equal to leading coefficient of the numerator, and B is equal to leading coefficient of denominator. And all that can be found in your packet that was handed out on Friday. So, looking at our original problem, you can see that the degree of my numerator is 1, and the degree of my denominator is 2, and so 1 is less than 2, so I have a horizontal asymptote at y is equal to 0. The fifth thing that we studied today was the x-intercepts. And I find the x-intercepts by set the factors left in the numerator equal to 0 So in this case, I don't have any factors left, I just have 4. And so in this case, 4 does not equal 0, so there's no x-intercepts. And then the last one, 6, the y-intercepts, let x equal 0 and solve for y. So in the case of what I have left 4 over x minus 4. So I have 4 over 0 minus 4. So 4 divided by negative 4 is negative 1. So y is equal to negative 1 is a y-intercept. So that kind of goes through it, and now as I talk about the next one, you'll be able to understand. And you can pause and write this stuff down or rewind me. So the next one I'm going to look at is x minus 4. So 3 is going to be f of x is equal to x minus 4 over x plus 4. So my first thing is discontinuity. There is none. The vertical asymptote, I set x plus 4 equal to 0, so there is a vertical asymptote at x is equal to negative 4. Horizontal asymptote, 1 is equal to 1, the degrees are equal to each other. So I look and see what my my situation would be, and so it says the graph is a horizontal asymptote at y is equal to a over b. So y is equal to the leading coefficient of a over the leading coefficient of b, so y is equal to 1. My next is my x-intercepts, and here I set my numerator equal to 0 and solve from there. So I have an x-intercept at x is equal to 4. And then my y-intercepts are going to be I set x minus 4 over x plus 4, and it's 0 minus 4 over 0 plus 4, and that way you have negative 1.